Hello, everyone, and thank you for attending my talk. Today, I'm going to talk about a recent series of 3 studies that we've just wrapped up and have published that has looked at the effects of low target odor frequency on detection canine performance and methods to try and mitigate these declines. I'm Nathan Hall. If you haven't already seen some of my other talks, I'm the director of the Canine Olfaction Lab at Texas Tech University, and we collaborate with the Forensics Analytical Chemistry and Odor Profiling Laboratory at Texas Tech as well. First off, instead of making this sort of an end note of everything, I wanted to put this at the forefront that the acknowledgements for the team that all contributed to these projects is Edgar, my current postdoc, Sarah Kane, PhD student, Mallory, another postdoc in my lab, and Lauren Fernandez. They're the ones that actually do the day-to-day work and are really the drivers and the main reasons why you'll see the results you'll see today. So what are we talking about and what are we interested in? So one of the things that detection dogs do a vast majority of the time is actually find nothing, right? We have detection dogs to detect things, but in a lot of operational scenarios, they actually don't detect anything. And in fact, most of their job is clearing and or not detecting things, particularly in the case with explosives. Thank goodness, right? But the phenomenon that we're going to talk about is a situation, well, what does that produce behaviorally, right? If the dog is trained to find something, but there's nothing to find, what kind of impact does that have? And this sort of potential issue hasn't, just arisen from our work. There's actually been a couple of studies in the past that has previously demonstrated that. The first one was by Gazet et al. In 2005. And what they showed is that basically dogs could walk down 2 different paths. Path A might have an explosive that is present along that path every single time the dog searches that area. And then path B, the dog might walk past that path and there's 0 targets present. And then you repeatedly walk the dog down that path for a number of times when there's 0 targets present. Path A, there's always 1 target present. Then after a certain period of time, you present a target along path B, and what you find is that there's reduced search and actually a low probability of detection along that path B, even though they can do the exact same thing, find the exact same odor along path A. And that it can actually be somewhat difficult to recover. And this was sort of considered context specificity, that the dogs can learn that along one area, there's a high probability of targets, and along another, there might be a low probability of targets. This was later followed up and confirmed in 2015 by Port et al. As a project with DSTL and Auburn University, where there were different groups of dogs, and one group of dogs would engage in repetitive search in different areas where there were 0 targets present. Some would find 1 target, some would find multiple targets, and some would find an arbitrary target that was present. One of the things that they found is that the group that had 0 targets present showed reduced vigilance, meaning that they searched fewer areas or they checked fewer areas, and they showed poor detection performance. Interestingly, though, the group that was able to even just find an arbitrary target that was successful in maintaining search and actually responding for the actual explosives as well. But what this highlights is that a situation when you have lots of areas to search with a very low probability of target, this could potentially lead to problems that need to be addressed. And the purpose of this project was to explore this in a bit more depth and try and identify additional solutions that might allow you to maintain performance when there are low targets. The arbitrary odor solution is a great solution, basically something that the dog is also trained to find being put out in the area that the dog can search, but that's not operationally feasible for everyone and for all conditions. In other words, you may not always have another person to be able to lead something out ahead of time, or that just may not be possible within a packed and crowded environment that the dog might have to work in. So we were looking at a couple of different things. So the first thing we wanted to highlight is when the dogs are doing a detection task, it's a complex behavioral chain. So you can sort of consider the first link, which is there's some type of context or handler saying search or something that is triggering that this is now a search area, right? Detection dogs are not searching for explosives all times, everywhere, every location. There's some type of discriminative stimulus or context effect that indicates for that the dog needs to start searching. Then the dog engages in the first response, which is searching, and then would eventually come across the conditioned reinforcer, which is the odor. So what I'll point out here is that within this chain, the odor can serve as a discriminative stimulus that produces the alert or occasions the alert behavior, but it's also a conditioned reinforcer for the search behavior itself. So in response one, we actually have, let me just pull up my handy dandy laser pointer here. So in response one, what's sort of maintaining a lot of this behavior is actually coming across the odor. The odor is serving as a conditioned reinforcer to maintain that search behavior. And this is the first link. And then we also have the second link where then the odor serves as a discriminative stimulus, which occasions the alert response, which then leads to the terminal reinforcer of actually getting food. And what can happen, right, is if you have very low prevalence of your conditioned reinforcer, then you never really have the opportunity to express the second link, which leads to the terminal reinforcer to sort of maintain that whole chain. But in fact, what you can have is a context that indicates search, or a discriminative stimulus that occasions the search behavior. The search behavior does not produce any target odors. You could potentially have extinction of this search behavior between response one and the conditioned reinforcer. So what we wanted to do, or sort of objective one of this project, was can we actually model this whole system in a laboratory model? And the reason for this is that, as you can imagine, there's 10,000 things that can be impacting detection dog performance at any time. Could be wind, could be environmental conditions. We have other work showing things about environmental conditions, different learning histories, different handlers, 10,000 potential things that can be influencing performance. And we wanted to develop a robust model that would eliminate most of these extraneous variables that would then allow us to test a wide variety of potential behavioral mechanisms that might maintain that first link, that search to finding the conditioned reinforcer of the odor prevalence. So goal one was, let's just sort of develop a laboratory model of that. And then second was to evaluate a variety of methods to improve in the laboratory model that lead to performance improvements in the laboratory model. We actually tested 3. I'll give at the end QR links to our papers. But those 2 methods are the sort of more interesting ones, which I'll talk about today. And then the third one is, if we find something that is successful, is it successful outside of this laboratory model? In other words, would it generalize to actual operational teams? So goal 1 was to develop a laboratory model. What did that look like? We had a laboratory, or essentially a room. We have 3 different odor ports here, 1, 2, and 3. And essentially what happens is this little panel that's driven by a motor will go up, exposing the 3 ports to the dog. The ports themselves are made of Teflon, but then we have PVC that's exhausting the odor out of the room between each trial to make sure that the room itself doesn't start filling up with the target odor of interest and sort of overwhelming the room. That the odor stimulus itself is relatively tightly controlled to the box itself, so that the box, when in the intertrial interval, is actually under negative pressure. Behind here are 3 different boxes. These are our sort of custom-built olfactometers. Essentially, think of them as fancy plumbing or devices that use air instead of water. And essentially what they do is they push air through in a regulatory manner that's controlled by a computer that presents the air that contains the headspace or the sort of area or the air above whatever your target is of interest. And in this case, it was double-base smokeless powder, which is a very common energetic that's detection dogs are trained to detect. So we have 3 essentially independent replications of these olfactometers this way. This box controls port 1, this box controls port 2, this box controls port 3. So every odor is replicated multiple times within this sort of search pattern. Let's actually see what this looks like for our dog. So Bruce is going to search, the panel is going to go up. We have infrared beams that are monitoring every time the dog pokes its nose into one of these ports. And then the dogs are trained to hold their nose for 4 seconds in the port that contains the target odor. And then this is measured by the infrared beams. The port comes down, the olfactometers go under negative pressure to exhaust the odor outside of the room. And then it resets itself, ready for the next trial. So after the intertrial interval, the dogs have their food, the panel will come up, the dog will be asked to search. and then they will search the ports and then engage in a nose hold when they come across the target. So that was our way that we could sort of eliminate as many, factors as possible from the scenario. There was still a handler, but the handler was blind for all the trials. They didn't really have much of an influence on what was going on other than at a consistent time asking the dog to search. We had a panel that was controlling the intertrial interval, and we had olfactometers that were controlling the odor presentation to make sure that that was relatively stable. In addition, we conducted SPME GC mass spec of the odors themselves and of the odor ports to confirm the odor delivery, the absence of the odor during blank trials or during intertrial intervals, as well as monitoring the change of the odor in the headspace over the course of the experiment so that we could use the GC mass spec to tell us if there's any changes in the odor profile, which would allow us to refresh the odor to make sure that we had a consistent odor profile across the entire sort of gamut of testing. So with that sort of being the laboratory component of the actual detection task itself, how did we then model the potential problem here, right? Which is that you might have one context where there's a high frequency of finding a target. Then you have an operational context where the dog is deployed to working areas where it's difficult to control the number of potential training aids or targets the dog could find, where there's a very low target frequency. So in the training context, essentially, we had one room that looked identical to the room that you just saw. And essentially, the only real difference that we had there is that 90% of the time that of trials, or 90% of the time, the handler said search, there would be a target odor in one of those 3 ports. So 90% odor prevalence, so 9 out of 10 trials, there was going to be target odor present for the dog to respond to. The dog would then engage in alert and then get the terminal reinforcer. Again, with the odor being construed as a conditioned reinforcer for maintaining that actual search behavior, going up and searching for the different odor ports. We picked 90% here as a training context because prior to this experiment, we had done another experiment with a wide variety of handlers where we surveyed a handful of different questions. And one of those was, how frequently during training or in training scenarios does your dog ever search an area and not find anything or ever have a blank in that? And the answer was between 0 to 1 time. So we picked 90% as a general rule of thumb that typically most training sessions would never even include a blank under what is current standard practice, to maybe 1 blank per training session. Then for the operational environment, we had the exact same context, just a slightly different room. But the only real difference here is that search led to a 10% odor prevalence. So here, out of 10 searches, there would only be 1 search in which the target odor was present in one of the 3 odor ports. So everything else was identical. The only thing we changed is the frequency that the target odor would appear in one of those ports, either being high or low. And we separated this by context, or basically by training room. The 2 training rooms were identical. And this was built to try and mimic the situation where you might train your dog in one general area or potential context, and then you have to deploy the dog in another operational area where you don't typically train. And that typically has a very low odor prevalence rate. So did this actually produce the effect that we thought it might produce, or based off of the previous literature? So a little red here just showing, that there was about a 10% odor prevalence, or very infrequent prevalence of the target odor being the condition reinforcer. So there was a potential that search behavior might undergo extinction. So in this case, the training context, we found overall 97% of the trials, there was adequate search. Some trials, there wasn't adequate search, meaning that they poked their nose into all 3 boxes or poked their nose into the box that contained the odor. It just meant that they actually got to the odor itself, and that happened 97% of the time. What happened the other 3% of the time? Well, because everything was under computer control, a butterfly might show up or a fly might come out, and then the trial terminated because the dog was chasing that. There could be all variety of things, but because it was under computer control, it was pretty strict in terms of what counted as what. But nonetheless, there was a 98% probability of alert if the dog got its nose into the odor port. So in this case, if the dog hit the odor, came to the odor, got its nose inside of that odor port, there was a 98% probability that they were going to alert. When you count into the factor their performance on the blank trials and other things, there was an overall mean accuracy of 93%. What happened in the operational context? Well, the main difference is that we actually saw 47% of the trials terminated with adequate search, meaning that the dogs poked their nose into either all three ports if it was a blank, or got their nose to the port that had the target odor. That only occurred 47% of the trials in the session. Interestingly, however, if you specifically look at the situations where the dog gets their nose, and we can measure this via the IR beams, into the odor port that contains the target odor, there's a 98% probability of an alert occurring. It was basically identical to what occurred in the training context. Essentially meaning that if the nose got to odor, that was not impacted. So the overall accuracy change here was 33% versus 93%. But this change was not driven by the fact that the dog forgot the odor, the dog couldn't remember what odor they were doing, maybe they got tired of finding the odor. The dog's performance could be, rock star in one context and not so great in the other context, but it was purely driven by this deficit in search behavior. Because if they could still get their nose to the odor port, which would typically occur either in the early trials, or occasionally the dogs would sort of get to the actual odor port and search it properly, that performance maintained if they could actually get that nose to the odor port. So what does this tell us? Or what does this tell me? And it tells me, if we sort of go back to this initial sort of chain, is that this second link, if the dog encounters the odor, it still maintains and serves a perfectly adequate discriminative stimulus function, such that if it gets its nose to that odor, there's still a really high probability that the dog would engage in alert response, and then the terminal reinforcer obviously would come. Where we're seeing the main deficit is what we would say in this first link, is that under a particular type of discriminative stimulus that indicates to search, so in this case, the person in the room saying search, or the context of that particular room, and the dog searches, and there is a low probability of coming across the odor, this conditioned reinforcer, then we have a substantial decline in this first link. So this first link here is 33% of the time in the operational context, but this part, even in the operational context, remains at 98%. So the second link is remaining entirely intact, but the first link is what is problematic. If you don't believe me yet, here are the actual results, and the actual sort of overall accuracy performance. So on baseline, both rooms, both the sort of training and the operational room, have a 90% odor prevalence. So 9 out of 10 trials, the target odor is going to be present, and dogs have excellent performance in both of those cases. In the testing scenario, all we do is just change one little manipulation in the code that changes the frequency in one of the rooms from 90% of trials present an odor to 10% of the trials. And then we see this immediate substantial decrement in performance occurring within the very first session, which maintained across the sessions. This little blue square over here was a control session that we ran, which is basically we plug the olfactometer in with all blanks and make sure that the dog doesn't find sort of a target. This is just a control to make sure the dog's not picking up on any noises or other cues of the system, indicating that their performance is actually completely maintained by the odor itself that we think it is, which in this case was double base smokeless powder. So testing here created a massive decrement, but what happens if you just return to baseline, or you just change the prevalence of the target odor in this room, the operational room, from the 10% back up to 90%? Oops, went the wrong direction. And you have immediate recovery. In fact, you could flip a switch by changing one little setting in the program from excellent performance to inadequate performance. And this was just by changing and manipulating the frequency at which the target odor appeared in those ports. Okay. So now we can take a little breather, come back to our objectives. So our objective 1 was to develop a laboratory model of canine search performance decrement. And I give myself a green check here because I think we did an okay job sort of distilling this search task into the very specific components that we were interested in, and that we were able to get the search decrement performance that we expected based off of the previous literature. So now that we have a laboratory model of that, can we rapidly test different kinds of methods to see if any of them would boost performance in any particular way? So objective 2, moving on for just a second, would be to evaluate 2 methods and identify improvements in the laboratory model. Okay, so what was method 1? Method 1 was to look at the concept of using non-contingent reward, non-contingent reinforcement, depending on what terminology you want to use, or essentially delivering of reinforcers on some type of time-based schedule. And the concept of this is that perhaps a dog is searching for some period of time, then they're not coming across the condition reinforcer of the odor. We could just deliver the terminal reinforcer on some kind of schedule so that essentially they get like a play break, if you will. So the dog would just get that reinforcer, whether it be food or toy, for some period of time, whether or not they find that target. So it'd be non-contingent on actually finding the target and making a response. It's just coming off of some type of time. So could you take a little break, deliver the terminal reinforcer, play with the dog, give them a little bit of food, and then their performance would immediately recover. Would that sort of helps, reduce the separation between one scenario where you have a high target odor rate, so you have a high delivery of terminal reinforcers, versus the other scenario where you have a low target rate and a very infrequent delivery of target reinforcers? Can you just increase the rate of target reinforcers to make that operational setting sort of quote unquote more fun, but also make it less different than the actual training scenarios, because you're still getting a high rate of delivery of that final target reinforcer? So to look at this concept, the dogs initially started off in their 90% odor prevalence training condition, as we had previously. And then they alternated between this and their 10% sort of odor operational condition. So just like what we saw in the previous figure, where the dogs would experience their training context at a 90% odor prevalence, and then their experimental context at a 10% odor prevalence, they would alternate between these 2 different conditions on a daily basis, between the 2 different rooms that were producing this. To look at the effect of the sort of non-contingent reinforcer, non-contingent reward, we would deliver a free reward, if you will, or non-contingent reward on 1/3 of the trials that occurred for the experimental group. So after 3 trials on average, or about 1/3 of the trials, the trial would terminate, the panel would come down, there would be a 5-second delay, and then there would be, the computer would give a whoop. This was randomized. It was not every 3 trials. It was on average 1/3 of the trials. So it was unpredictable of when this sort of non-contingent reward would be delivered, but it was on average 1/3 of the trial. So it was relatively heavy. So it reduced substantially the change in the number of reinforcers between when there was high prevalence of target odors versus a low prevalence of target odors. The control group got none of these. It was just the exact same as before. When they were engaging in the 10% operational condition, it was still the 10% operational condition, and there was no non-contingent rewards being delivered. So what did the results look like? In baseline, when everybody had a high frequency of target odors, 90% again, both in the operational control, the 2 groups performed identically and excellently. So these last 2 days is actually part of the recovery from the previous group, but overall they performed quite perfectly, right around 100%. And then in the test condition, these 2 lines up here are going to be the training context, where there's a high prevalence of target odors. And then these 2 down here are going to be the sort of quote unquote operational context, where there's a low prevalence of target odors. Our squares here are going to be indicative of the group that received that non-contingent reward schedule on top of the regular schedule. And the circles here are going to be the pure control, which was just the regular 10% prevalence with no additional non-contingent reward delivered. There's perhaps weak, although non-statistically evidence that maybe in session 1 there was a little bit of boost of performance, but there really wasn't much of an argument to support the benefits of this procedure. And particularly by the end of session 4 and 5, we really saw no effect in here to write home about as any kind of difference in procedures. If anything, we did see a slight increase in false alarm rate, and this could be because occasionally that 1/3 of rewards would get delivered randomly based off of when a false alert occurred. The time between when the trial ended versus when the non-contingent reward was delivered could potentially be manipulated there. There could be signs of evidence that there might be some parametric manipulation here that might work, but we didn't get excellent evidence to say this is a great new procedure. Again, just like before, recovered really quite quickly across the groups once both groups returned to a 90% target odor prevalence rate. So it was a procedure. We give myself one check because we did evaluate a method. I never promised successful results. I just said I would evaluate it. So method 1 wasn't really a successful method. It might get a small boost, but it quickly went away. Nothing really to write home about, nothing necessarily to provide as a recommendation. But nonetheless, it did demonstrate that we were able to evaluate a method using the laboratory model and allow us to sort of move on to other potential concepts. So the next concept we wanted to explore was, the 90% odor prevalence that has really high frequency of trials in which the target odor appears. Well, perhaps we can build resistance to search extinction using essentially the partial reinforcement extinction effect, which is that intermittent schedules of reinforcement tend to be slightly more resistant to extinction. So obviously extinction is inevitable. So if you completely cease the prevalence of target odors in a case where the dog is going to be searching for long periods of time, search behavior is going to extinguish. No matter what you do, it's just going to be a behavioral phenomenon that will occur. But that rate may not occur equally or may occur at different rates based off of different types of training experiences that the dog might have. In other words, that is, some responses might be more resistant to extinction. Generally, the partial reinforcement extinction effect indicates that responses under intermittent schedules of reinforcement tend to be more resistant to extinction. So one of the concepts as to why this is effective is that it's likely because it occurs more difficult to discriminate that reinforcement is stopped because you've always previously produced responses not always followed by reinforcement. But this doesn't immediately make sense to you. Give me just a second. What this suggests is that the partial reinforcement effect is partially about making it difficult to discriminate or tell the difference between situations in which you are under extinction and situations in which you're still under reinforcement. So to give an example, I like to try and break this down a bit, is that you like to compare the Coke or the vending machine versus a potential slot machine. So the Coke machine, we know, is typically under some type of continuous reinforcement schedule, right? You put in your money, you push a button, you get something back to you. Whereas your slot machine, you put in your money, you push a certain button, there's a small probability that something's going to come back to you. You probably have some experiences of having some reinforcers being delivered, but you probably have a very extensive history of reinforcement where there's many trials in which you do not get a reinforcer. In other words, you have lots of experience of non-reinforced trials, or trials where you're pushing the button or quote unquote searching and not coming up with anything or not winning anything, your conditioned reinforcer of coming up to an odor. Whereas your Coke machine, you have very few situations in which you put in your money, push the button, and nothing comes out. In fact, after you put in your money one time, you push the button one time, and nothing happens, you probably have already understood or clocked the fact that your reinforcement schedule is now different. It's not the same as it previously was. It makes it very easy to discriminate that something has changed. In fact, just after one time that you've pushed the button and didn't get your reinforcer here, many people will just completely stop responding. Some people will show extinction-induced sort of emotional variability, right? Some people will show extinction-induced behavioral variability and end up with the Coke machine on top of them as one way to try and shake it and get it out, right? Many times it only takes one response, maybe two responses. Very rarely does it take three responses until you have sort of extinguished putting money back into the Coke machine. However, your slot machine, on the other hand, you've had lots of previous experiences where you would eventually get the reinforcer, but it's after many of non-reinforced trials. So it maintains that persistence. But imagine in the same situation where the Coke machine breaks, imagine someone goes behind the slot machine, flips a little button that then says, don't pay this out ever, right? That it's now broken. So you put your money in, you push the button, does its normal thing, but nothing comes out. And then push the button, does its thing, nothing comes out. Push the button, does its thing, nothing comes out. How long would it take until you recognize that something has changed and that you're no longer on the same schedule of reinforcement and that actually those reinforcers are no longer being delivered? Typically, that would take a much longer period of time because you have learned that this particular scenario does produce reinforcers, but at a much thinner rate. So it takes longer until you can appropriately discriminate that the contingencies have changed from some type of reinforcement schedule to an extinction schedule. So how do we sort of apply this back to our detection dogs? So if my previous argument has been to date that the effect that we're largely observing is this effect where there's some type of discriminative stimulus that indicates for the dog to search, the dog searches and does not find the condition reinforcer, does not find odors not reinforcing this part, and this effect is mostly due to extinction of response 1 with conditioned reinforcer 1, then perhaps we can make this component on a more intermittent schedule, essentially making it harder for the dog to discriminate between whether the sort of reinforcement contingency changes between the number of searches, in our case, the number of boxes the dogs have to search, or you could construe it as duration of search to the frequency at which target odor appears. So if through training we can build intermittency into this component of the schedule, we know that this component remains untouched under our conditions of very few target odors. So all we need to do is build some intermittency into this schedule, and perhaps we can get the whole chain to be more robust to the situation where there are very few target odors. So how did we do this? So in this task, we're sort of searching for solution 2. Half of the dogs underwent a training procedure where we increased progressively more blanks incorporated into training, until ultimately about 80% of the runs or 80% of the trials the dog would search the different ports did not contain a target odor. And if you remember, the challenge that we typically do is 10% target odor frequency. So this is basically bringing the dogs down to a 20% target odor frequency. So we started them off at 90, then gave them sessions at 90 until they reached performance criterion, then 80 until they reached performance criterion, 70, 60, 50, 40, 30, 20. And then our control group of dogs just maintained at the regular 90% frequency of target odors appearing as they had in previous training. So dogs went through baseline, half went through this progressively intermittent schedule of target odor appearance, or basically more intermittence of that initial link in that chain, or more intermittence of the frequency of which the target odor would appear in one of those trials. And the other half was trained at that constant 90% odor frequency. Then we challenged all dogs in the same context before, where they would rotate between a high prevalence, odor prevalence of training versus a low prevalence, or 10% in the operational training. The dogs in the experimental group, sort of their odor training was maintained at what they ultimately went down to, because we wanted to try and essentially reduce the variation between the training context and the operational context. So the experimental dogs were rotating between their 20% odor prevalence and their 10% odor prevalence as a test. Then the other dogs were rotating between their typical 90% and the 10%. So this would be comparing working in an operational environment with very infrequent targets, but then when you get on a training day, you put out lots of targets, the dogs have lots of finds, it's lots of fun, versus a situation where in training, you are building that intermittent frequency of which searching leads to the condition reinforcer of the odor, or sort of building towards that lower odor prevalence that is going to be more similar to your operational environment. And what did we find? So by this time, and again, it's important to note that the same dogs sort of participated in these different experiments. So by this point, the dogs in baseline were rock stars. So when you have 90% odor prevalence in both of the conditions, they're cruising along at 100% quite easily. Then in the training context, triangles here essentially are going to be the dogs that maintained at 90%, and then the, which you can't really see so much behind, are going to be the little crosses. The crosses are going to be the dogs that were experiencing that lower and declining frequency of target odor prevalence. So as you can see during training, even though that their target odor frequency was getting lower and lower and lower every single day, they were still maintaining excellent performance. We were able to slowly reduce that so that by the end of this time, they could maintain excellent performance at a 20% odor prevalence, or 80% of the trials were blanks. Then we challenged all of the dogs in the same sort of experimental condition again, where the 10% operational is going to be slightly lower. And these blue squares here are experimental dogs. So as you can see, these dogs in the operational context substantially outperformed the dogs here that are in the control group, or the dogs that had the continuous 90% odor prevalence conditions. So we had a pretty nice separation here of 20+% in total accuracy, and that these dogs were able to maintain performance both in the training and in the operational condition substantially better. There was a slight overall lower rate in comparison to the training at 90%, but the nice thing about this is essentially, it's what you see is what you get. What you see in training in terms of performance accuracy is actually what you get in the operational context, because you reduced the massive sort of discrepancy in odor prevalence between those two conditions. So, coming back to our objectives, I already gave myself a green check for the laboratory model of canine search performance. Given myself 2 checks now for evaluating 2 different methods. We evaluated method 1, which was that non-contingent reward scenario, which was not good. We evaluated it, but again, as I said, we never promised good results. But then the second one was using sort of that partial reinforcement extinction effect to try and increase the resistance to extinction of search behavior, that first chain component, by making the odor frequency more intermittent, like it is in the operational context, so that those 2 contexts become more similar in that ratio of search behavior to finding a target odor, that condition reinforcer. That actually did seem to produce a pretty substantial boost in performance in comparison to the control condition, where you maintained at that really high rate of odor prevalence. And again, I didn't have the data here, but again, that second link maintained at about a 98% prevalence of finding the target odor, or getting the nose into the odor port that the dog would actually alert. So that second component of that chain essentially remains untouched. That's super robust. So in other words, we have no real degradation across any of these manipulations of the dog not being able to respond appropriately when it comes to the odor. What the issue largely was getting the nose to the odor in such a way that the dog could sample it. And in one case, we would have a substantial extinction of that search behavior that would get to the odor. In the other case, we were able to build more persistence and resistance to extinction in that. So now our third objective was to try and extend this procedure to operational teams. In other words, could we actually take what we have done and translate this outside of our simple laboratory model and bring it to dogs that have already been trained from a wide variety of different ways. They're all explosives detection dogs, do a similar type of procedure and see an impact on their performance. In other words, could we actually, in a relatively quick period of time, change the performance of operational detection teams? So what we did is that we found 23 operational federal, state, city, and private detection canines. So these dogs came from multiple municipalities, multiple cities across the United States. We all sort of traveled with our olfactometer boxes. First thing you might notice is that the boxes are now independent instead of having this little panel that then with the motor comes up. We learned that the motor was a total waste of time. It sure looked cool. I was very excited when I first put it together, but it really had no particular behavioral relevance whatsoever. And then we just took the little boxes and sort of packaged them up as their own little thing and then connected them via Bluetooth. So these boxes are connected to the Bluetooth, which is run by a computer, which has my postdoc Edgar here sitting in this kind of like little warehousey area. We did a manual alert system. So because these dogs were not trained by us and they were previously trained, these are dogs that are working every single day. They all had very different kind of alerts. Some would sit, some would lay down. Most of them, almost none of them, would actually hold their nose in the odor port. That was not a part of their sort of trained response system. So we had a manual trigger of an alert. So if the dog alerted and made a sit, the handler would call out the number that was associated with this particular box that was printed on it. And then Edgar would enter it into the computer, and the computer would spit out whether that was correct or an incorrect response. Okay, so we got 23 of these operational teams. We did an initial qualification period to make sure that the dogs could respond to the target odor in these boxes, and that it wasn't very difficult to switch over. And pretty much all of the dogs acquired the task within 5 trials or just a couple of minutes. The only difficult thing is that the dogs had to learn to put their nose in the odor port rather than checking the seams of boxes, because typically the dogs learn to check seams of boxes because you have the material inside, but we actually have everything hermetically sealed inside, so they have to check the very particular port on the top. But once that transitioned over, with pretty much every dog were qualified at 90% or higher detection rates within 10 trials. Then we gave the dogs 10% odor challenge. So after we demonstrated that the dogs could use the boxes to find their target odor, we just made it so that out of, on average, 9 out of 10 searches, there was no target odor present in any of the boxes. And then we looked at that sort of baseline effect. Half of the dogs got trained with a progressive intermittent schedule, just like we did in the previous experiment. We went substantially faster here because these dogs are working, they're operational. We could only really get 5 days out of them to take them off of sort of the downtime. So we had a very quick schedule to try and fit this within their sort of operational tempo. The other half of dogs got trained with that constant 90% odor frequency, just as before. And then we challenged with a 10, 5, 0% odor challenge rate. So here's an example of the dog coming through searching. The dog searches different boxes, makes a response. The handler calls out the name of the box. Edgar adds it in. The computer makes a response to indicate that was correct, and the handler delivers a reinforcer. So handlers held their own dogs. We had no involvement in that. They did however they particularly worked and how that they were used to working. We found in the qualification, all the dogs exceeded a 90% detection accuracy level, which would be typical of certification and at their typical standard levels. When we challenged them with the pretest, so we basically reduced the target odor prevalence down to 10%, we had a drop of about 30% in performance, so down to the high 60s. Then this is what the training looked like. So we have our control group. They would then sort of be recovered at the 90% target odor prevalence. The blue group was also initially recovered at 90% odor prevalence, but then we started moving them down to 80, 70, 60, 50, 40, 30, and 20, again, just like we did in the previous experiment. And what you can see is that even though this experimental group, we were lowering the prevalence, their performance actually tracked relatively similarly to the dogs that were maintained at that 90%. So it didn't really seem to have a very substantial decrement by just simply adding in greater intermittency between the search and the condition reinforcer of odor prevalence occurring. After we got the dogs sort of worked down or in between the experimental and control groups, we re-challenged the dogs again with a 10%, 5%, and 0% odor target prevalence. So this one at 0% is completely under extinction. So accuracy here is the dogs correctly making an all clear response, or searching each of the different ports and then indicating that there was nothing present, which is what the dogs are supposed to do a vast majority of their time. And then this is where at 10%, which includes did the dog actually hit their target, as well as correctly all clear when there was no target present. So as you can see, there was a large difference between, or not so much large, but an important difference between the experimental and control dogs, even when we were looking at dogs that were already operational, already met certification criteria, were already searching out in the real world, taking the same type of test and the same type of experiment and building in that sort of persistence, if you will, or resistance to extinction by making that frequency at which the target odor appeared more similar to what we would expect in the test or the challenge period, led to greater performances in the experimental group compared to the control group within even these operational canines. So the general conclusion was introducing progressively more blank runs or more blank searches or more blank boxes, however you necessarily want to do it, but introducing progressively more and more of these blanks where there was no targets essentially was acting as this kind of intermittent scheduled reinforcement for the conditioned reinforcer of the odor appearing, not the terminal reinforcer. The terminal reinforcer was always maintained at 100% in this case. We're really just looking at manipulating that first link, is what is that ratio or frequency between search behavior and that conditioned reinforcer appearing. What we found is that by manipulating that so that we had more search runs without the target odor appearing, and doing this in a progressive manner, built that resiliency or that resistance to extinction when the dogs were then challenged in an operational condition, or at least a simulated operational condition, where there were few to no target odors during this repetitive search task, which is a task that a lot of operational and working detection dogs do. So, coming back to the objectives, I think we developed a laboratory model of canine search performance, and we evaluated 2 methods that I at least present to you to identify improvements in the laboratory model. And then we were able to extend these successfully to operational teams, meaning that we could translate this effect outside of the laboratory, and this would work with dogs that were not trained by us, not procured by us, and that was just tested within an experiment in a brief period of time, that we still saw differences in performance based off of the prevalence at which the dog was trained, or that progressive schedule of the appearance of the odor within the sessions. So with that, thank you very much. Thank you for your kind attention. I do have 3 QR codes here. So what I just presented to you is actually packaged into 3 different manuscripts that came out of a recent special issue of Journal of Experimental Analysis of Behavior. You can scan these QR codes and it will bring you to a free copy of those 3 papers. Part 3 is the one where we were looking at that increasing the frequency of blank trials, or the progressive schedule of the number of blank trials or trials without the target odor. That's all in part 3. Part 2 is the one that has the non-contingent reward schedule test, as well as a different one that I didn't have time to talk about. And then part 1 is the one that actually demonstrates the initial laboratory effect, gives you all the information on how to sort of set that up, and links to actually how to build those all effect numbers if you're interested. Thank you to the funders, and ultimately everything I have to say here is only just my opinion and does not reflect anything about the sponsors. And with that, thank you for your time, and I will be seeing you soon. Thank you.